We're going to do a little bit more with multiplying monomials, but this time we'll have some multiple step problems. You can go ahead and do the 5-minute check on your own. However, I guess we can do the second step. It says draw the stair step and label the steps. So the stair step has 4 steps. We're not going to use all 4 right now, but we start with the exponents, multiplication, addition, and then nothing down here at the bottom. And you want to move down the stair step. Remember we talked about how the stair step is basically the order of operations, but it's missing a few of the steps. But you're going to start at the top of the staircase and move down. And one of the things that will help you also with that, we use something I call don't stay simple. And we're not going to totally get into this today, but we'll use that in the future. Don't is going to stand for distribute. So basically, if we have any exponents on the outside, we want to do that first. And then we're going to continue on the steps. These other two, especially this middle step, we won't get to today. We'll do that when we do dividing. So I guess we'll just do the don't and the simple today. But what we want to do is take care of this exponent. We want to get rid of these parentheses by applying this exponent. So if it's an exponent problem, remember we're multiplying. So we've got to do that first. So this becomes 2 to the second, x to the second, y to the 8th. Multiply as you distribute. And then let's change this to a multiplication sign so there's no parentheses left. Then we've got 2 to the 5th, x to the 10th, y to the 15th. So that's your first step. You're applying the exponent, and the rule is that you multiply the exponents when you do that. Now it's a multiplication problem. So we're here on the multiplication step, and this reminds us that we're going to add the exponents together. So 2 to the second and 2 to the 5th gives us 2 to the 7th. X to the 2 plus 10 is 12, and y to the 8 plus 15 is 23. And that's what you would do in a multiple step problem. So number 2, same thing. Apply the exponent first. X to the 4th, y to the 6th, n to the 2nd. That's what you get when you pass it all out. And then here we get x to the 3rd, y to the 9th, z to the 6th. Pass it out. And now it's a multiplication problem, so we add the exponents. We get x to the 4 plus 3 is 7, y to the 6 plus 9 is 15, n to the 2nd, and z to the 6th. You can keep them in the order that they're in. You don't need to change it to alphabetical order if it's not that way. So this is just fine. Now what about fractions? This is the one that causes some tricks here, and then we'll get into some others. Go ahead and do the first step. We get, let me draw a line here, 4 to the 3rd, a to the 6th. Now here's where it gets tricky. We're really raising 1/2 to the 2nd power. So let's just put that for now, and then a to the 6th. So what do we do with that? Okay, the a we can take care of. We are now multiplying these, so we want to add the exponents. We get a to the 12th. That part's easy. It's the coefficients that are always the problem. Now, I know that the base 4 and the base 1/2 are not the same. So the only way I will be able to simplify this problem is if I convert them all to just regular numbers. And so no exponents, just standard form. And I will do that by, first I need to figure out what 4 to the 3rd power is. So that's 4 times 4 times 4, which is going to be 64. And then I need to figure out 1/2 to the 2nd power. So really remember that's just 1/2 times 1/2. We multiply across the top, we get 1. And multiply across the bottom, 2 times 2 gives us 4. So this is what we have. 4 to the 3rd gives us 64. 1/2 squared gives us 1/4. We're not allowed to put 2 coefficients in a final answer. So now we have to take 64 and multiply it by 1/4. That is just 64 over 1 times 1/4, which would be 64 over 4. It's just a division problem. 64 divided by 4 is going to give us 16. A to the 12th. So the rule is only one coefficient base. So the 4 and the 1/2 could not stick around. So we have to actually expand the 1/2 to the 2nd, expand the 4 to the 3rd, so we can multiply them together. We'll have a couple others here. 4 4 is actually very simple. People look at that, they get confused, but we're just raising an exponent to an exponent to an exponent. So that means every time we're raising something to an exponent, we're just multiplying. So we're just going to multiply 4 times 5, which is 20, and 20 times 3, which is 60, and we get 2 to the 60th power. That's all we're doing. 3 times 5 times 4 gives us 60. We're just doing it multiple times. 5 and 6 are going to continue with the same rules that we did here in number 3, because we had different coefficients there. Here we have the same base, 2 and 2, so you can leave it in exponent form. Here the bases are different, so we have to expand them. Now, knowing that, you can tell from the beginning of the problem if you're going to have to expand them, and you can save yourself a step here. So I have a base of 4 here and a base of -3. I know I'll have to expand them so that I can multiply them together to get one coefficient. So instead of writing 4 to the second power, 4 to the second power is 16. So I just go ahead and expand it in the first step so I don't have to do it later. The rest is pretty easy. C to the second, D to the fourth. We're raising it to an exponent, so we multiply the exponents. Now that doesn't mean 4 times 2. It's still 4 to the second power, and then we expand it in our head. This one's tricky, -3 to the second power, so we're doing -3 times -3, which, again, it's a negative raised to an even is going to make it +9. And then we get D to the 6th. So let's do the variables first. Actually, let's just do it all. So now we have two bases that don't have exponents on them, so we can multiply them together. 16 times 9 will give us 144. C to the second stays that way, and D to the fourth and D to the sixth gives us D to the 10th. Always, you pause, rewind if you want to watch it again. I'm going to keep moving, but if you need to go back and play it multiple times, then that's what you'll have to do. This one works just like this one. Again, I see that there are two different bases, a 2 and a 3. So we want to go ahead and expand them as we're working to save us some time. So instead of writing 2 to the 5th power, let's multiply that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. Then we get A to the 10th, G to the 15th. Here we've got 3 to the 2nd power, that's easy, that's 9. And then A to the 12th, and G to the 16th. So distribute that exponent by multiplying, and now we've got two base exponents, two coefficients, don't have any exponents. 32 times 9 is 288, A to the 22nd, G to the 31st. So multiplying monomials with multiple steps, okay? We're going to do one other thing, that's perimeter and area, or finding area, with exponents. So we do probably have to backtrack a bit, see if you remember what the formula is. For a rectangle, the area is going to be length times width. For a triangle, remember a triangle is just half of a rectangle. So we multiply the length times the width to get the whole rectangle, and then we cut it in half. So 1/2 of length times width. And that's really half the battle. Usually for these problems, and the length and the width are actually pretty basic. So we're really only doing 4a to the 3rd times 2a to the 2nd. That's a multiplication problem. So we go a step down on the stair step, and we add the exponents. So we get a to the 5th, and 4 times 2 gives us 8. So that's going to be units, because we don't have a unit. And then here, 1/2 length times width. The length is 10x to the 2nd y to the 5th, and the width 2x to the 4th y. And these are commutative, so it doesn't matter what order you put them in, whatever you want to call the length. It's the length. I always call the long one the length, but it doesn't really matter because we're multiplying them together. Now, let's do variables first. X to the 2nd, x to the 4th, that's x to the 6th. Y to the 5th, y to the 1st, that's y to the 6th. And then all these coefficients are going to get multiplied together. So probably the easiest way to do it is skip the fraction for now, or actually you can go 1/2 of 10. 1/2 of 10 is 5, and 5 times 2 is 10. You could also think about it this way. The 1/2 and the 2 are going to cancel each other out, because 1/2 of 2 is 1. And so we're left with 10. And that's going to be units. You know what? This should be units squared because we're talking about area. Area is always squared units. So length times width, 1/2 length times width. If you're uncomfortable with that, you can always do 10 times 2 is 20 and put it over 2. There's lots of different ways to think about it. Some people like using the formula length times width over 2. That means exactly the same thing. Whatever you want to do, make you more comfortable.